Alright, in this video, I'm going to be talking about binary, what binary is, how to count in binary, and yeah, okay. So let's start with my explanation on binary. In our current modern world, like 99% of the population and all governments work on the principle of need to use numbers. Okay, we all need to use numbers in counting. We need to count how much money we have. Um, I don't know how many teeth we have. Basically, counting is very important, and the whole world uses the Arabic counting system that has been adapted to look like this today, with these symbols, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. But let me clue you in, right? Or let me give you some information about our counting system. In mathematical terms, this counting system that we use is a base 10 counting system. Okay, what does that mean? That means that there are only 10 symbols in our entire counting system. You don't believe me? You start from 0, then we count up, okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then what's after that? 10, right? But notice how when we go to 10, we actually have to add one number in the tens place. This is the tens place. You learned this in primary school. You have to add one number to the tens place once you reach 9. And once you reach 9, actually, you have gone through 10 symbols. You have gone through 10 symbols. So that means because you only have 10 symbols, it's a base 10 counting system. After the 10th symbol in the ones place, you have to add 1 in the tens place. Wow, I just said a lot of stuff that you're not going to understand. Okay, so why am I telling you this? Well, I'm just trying to make connections because with binary, binary is a counting system as well. It is actually not so different to our base 10 system that we use today, except that binary is a base 2 counting system. So you can use the skills of deduction or inference. It's pretty easy to tell that binary only has two systems, two symbols in its entire counting system. And that is known as 0 and 1. That is it. That is the entire counting system. That is it. So let's try counting. Let's try counting in binary. Okay, we have 0, we have 1. Then what comes next? We've run out of symbols already. So as we do in the normal base 10 counting system, once we reach 9, we add 1 to the tens place. Aha! So we do that exact same simple thing for binary. 0, 1, run out of symbols, add 1 in the tens place. Damn simple. And then notice our ones place becomes 0. We do the same here. That's it. It's that simple. So 0, 1, 1, 0, or 10, but we don't say 10, we say 1, 0. So what comes after this? What comes after 0 in our base 2 system? 1, right? Then, simple, right? You add 1 and you get 11, or 1, 1. Then now, we reach an issue again, because after 1, we got no more symbols. So we add 1 in the tens place, right? Correct? We add 1 in the tens place. But oh no, our tens place is 1 also. And after 1, there are no symbols. So what do? We add 1 in the hundreds place. And then from this, we'll get 1, 0, 0. That's how easy it is. Once you run out of symbols, you just add in the next place. And you keep doing that. That's it. That's it. So let's do a little test, okay? Because this is so simple that you cannot fail this. Okay? Let's do a simple test. Okay? I'm gonna talk about these numbers, binary numbers, and then I'm gonna ask you what comes next. Okay? So in this binary number 10010 plus 1 in binary, what do we get? You can pause now and try. Okay, we get 10011. Very simple. Let's move on. Next, we have 10011 plus 1. What do we get? You can pause now. Okay, we get 10100. Why? Because this is in the ones place, this is in the ones place. We have to add together. Oh no, no more symbols. Add in next place. Oh no, no more symbols. We add here. These get reset to 0. Damn simple. Okay, next, last one. 1111 plus 1 equals what? Okay, answer is 1000. Okay, 0. Why? Ones place, add here. Oh no, no more symbols. 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 Add here. That's it. That is binary counting. That's it. Okay, but just looking at this, this is kind of useless. You may one good question to ask is, okay, Nikki. Now okay 10010. Okay, so what? A good question to ask is, how do I convert binary back into our base 10 system, which is decimal? I forgot to say this at the start. This counting system is known as decimal, the decimal counting system. Okay? So how do we convert binary back to decimal? Very simple. Very, very simple, okay? First, let's say we look at this number. Let's say we look at this number. How do we know to convert this back? Well, there's a few ways we can do this. We can first use our hands. Okay, this is quite an interesting thing to do. So I'm going to ask you to stick out your hand. Stick out your right hand, actually. And what we're going to do is we're going to form a fist in our right hand, okay? So your fingers should be tucked into each other, and your thumb should be tucked into outside your fingers. So you should be holding a fist right now. And then what I want you to do is tell yourself, okay, this is 0. Right now you have the value 0 in your hand. Then next, lift up your thumb. Oh, okay, wait. Let me talk a bit more about this. Your fingers and your thumb right now is clasped down. All your fingers and thumbs is at the value 0. When you raise a thumb or when you raise a finger, that finger or thumb's value is at 1. So basically we have binary in our hand. Okay? So what we can do, lift up your thumb. Notice how everything is 0, your thumb is 1. Therefore, right now you have 1 in your hand. Then now, I want you to add 1. Try and add 1 to your binary now. Your binary hand now. Try. Okay. If you have in your right hand all your fingers and thumbs closed except your index finger, you are correct. Then you add 1 again. Add 1 again. If you have in your hand all your fingers closed except your finger and your thumb, you are correct. Basically, you just use what you just learned and put it in your hand. Damn simple. Okay, how can I use this to convert it to decimal? When you're doing this binary counting, you can actually count in your head in decimal. For example, I have 0 in my hand now. In binary, I can say 0. Then my thumb is up. Is binary 1, I can say 1. Then everything is closed in my hand except my index finger. I can say 2. And I can keep doing this. I can keep doing this and keep adding the decimal number in my head and keep doing this motion in my hand. And when I see in my hand, I have 101101, and then I can use the count in my head to get that binary number. But Nikki, I only have 5 fingers. I only have 4 fingers, 1 thumb in my hand. How can I get? There are 6 digits there. How can I get? use your left hand. You can use your pinky finger to convert from your right hand to your left. Then you can make with your hands a 10-bit binary number. What is a bit? You know how we have digits in our counting system? In our decimal system, this is 1 digit. These are 2 digits. In binary, we have the same thing, but we change the word digit to bits. This is a bit. These are 2 bits. These are 5 bits. That's it. Okay. So that is one way, but that is quite a hard way to do things. So Nikki, how do I have maybe a mathematical way of converting binary into decimal? I'll tell you. But first, I need to do something. Okay, it is very, very simple. Look at each individual bit. We have 1, 0, 1, 1, 0, 1. Oh, wait. Before we do this, can we get a count of this? Use your hands and try to get a count of this. I'm going to do it as well now. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 22, 23, 24, 25, 26, 27, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44. My count is 44. Okay. Let me use a method to verify this. You don't have to worry about what that method is right now. Give me a second. Oh, I'm wrong. It's 45. It's 45. So if you got 45, good job. Okay. So is there a mathematical way or not to convert binary into decimal? Yes, there is. You look at each individual bit. You see how this bit is 1, this bit is 0. What you need to do is also notice that this is in the ones place, yeah? That's in the ones place. Or rather, sorry, this is like your... Oh, you also need to know something. You notice how this is the ones place, right? In binary, we also have that ones place, but we actually have another name for it. We call this the least significant bit. And then in our binary number, right, the number that is furthest, the bit that is furthest away from the least significant bit is known as the most significant bit. And these two terms you must know. Okay? Okay, so the mathematical way is we assign a number to each place. This is the ones place, right? We assign 0. This is the tens place, we assign 1. Hundreds place 2, 3, 4, 5. Okay, that's it. Next, we take this digit 1 and then we multiply by 2 to the power of this number, so that'll be 0. And we do that for the rest. So it'll be 0 times 2 to the power of 1. This will be 1 times 2 to the power of 2, 1 times 2 to the power of 3, 0 times 2 to the power of 4, 1 times 5 to the power 2 to the power of 5. And then we will get a number for each of these. So I'm going to get my calculator now and I'm going to get what this is, okay? So for here we got 1, this is 0, this is 4, this is 8, this is a 0, so this is 0, and then this is 32. Okay, so what? Now, you have all these numbers, right? Add them up. And guess what we get when we add all these numbers up? We get 45. That is the mathematical way to convert binary into decimal. There's one more cheaty way that you can convert binary to decimal, and that is using your calculator. I'm going to teach this using a Casio FX97 SGX calculator, but if you find a way to translate my actions to any other calculator, it should be fine. Right now, I'm in mode 1, which is calculate, and what I'm going to do, right, is I'm going to put in, okay, let's say I want to convert decimal into binary. How can we convert decimal into binary? I'm going to use my calculator, and I'm going to put in 45 and press equals. Right now in my calculator, there's a variable, and 45 is stored. Now I'm going to go into mode 2, and I'm going to press binary. The blue text that says binary on the button, I'm going to press that. Now I'm in binary mode. I'm going to press uns, and I'm going to press equals. What you should see is 1, 2, 3, 4, 5, 6, 7, 8. You should see a 32-bit number. You should see a 32-bit number, and you'll see your answer there. So that's it. Very, very simple. Okay. Yeah, this calculator. Yeah. So you can ask me now, how do I convert binary to decimal then? So okay, let's put in this. I'm gonna go back into mode 1. I'm gonna type in 101101. Oh no, wait. Okay, with my calculator, I'm not sure how to convert binary into decimal. But I just taught you with your calculator how to convert decimal into binary. So yeah. Okay. Anyway, that is answering the big question. That is how binary is useful. Because now we know that we can use binary to actually count things. And we know how to convert binary into decimal, and we know how to convert decimal into binary. And we also have learned about the least significant bit, most significant bit, which is actually rather important. And that is that is pretty much all you need to know about binary. So thank you for watching.